Okay, so we have a question right here. Let's get started. So they say here, suppose A equal to X are element whereby X including -3 or more than 3. So it starts from -3 and more, and then or X is less than -3 means it goes all the way to negative infinity, start from -2 to 7. Which of the following statement is true? So we're gonna have to test each and every one, because now we cannot identify A intersection B by just saying, oh, this true, this not true. We're gonna have to test each and every one. So you know what? Let me tell you this. It's very important whenever they give this type of question, draw your number line. Number line is gonna save your life. Now let's start A intersection B. So we have A and B. Let me draw my line here for A first, and then we intersect with B. Okay, so let's read the line. Okay, what is that A? A is greater than -3. So let's assume this is 0. Let's assume this. So -3 is here. So if it's including means you're gonna draw like this. Okay, now we go. So that's our A. So this is A. So this is gonna be our A. So make sure you highlight, because they say it's greater than -3 means this side. It goes all the way to positive infinity. All the way to positive infinity. So this is our A. Now, so this is our A. I can just see it. Now we go for B. Where is B? No. A, yeah, A intersection B. What is our B? Our B is, it starts from 5 and then it goes back all the way. Okay. So this was -3. Okay, let's say this is 0. 1, 2, 3, 4, 5. Let's say 5 is here. So let's draw another number line. And then let's say this is 5. Is including, excluding. For B, because they say A intersection B, we want to check. B is excluding, so 5. Let's say this is excluding, so this is 5. So it goes to the negative infinity, that side. So you're going to say this way. Here, -5. Okay, now this is 5 to the negative. Now, so look careful, it goes all the way to the negative. So you're going to have to use your common sense now. You want to put them together, because they say we want to see if it's A intersection B, what that's going to give us. So when you intersect means you bind them together, join them together. Now, and then we're going to see where they have things in common, or where they intersect. So if you look careful, if we can bind them together, we see from here all the way to here, they're going to have something. Can you see? Because this one starts from -3 all the way, this starts from 5 positive all the way. So they're going to intersect starting from -3, but this is going to be including. You know why? Because here we have a member, we have an element, and here is including. So it's going to start -3 including all the way to 5 positive. So you're going to say to 5 positive, but this side is going to exclude. You know why it's going to exclude? Because even though here we have a member, so we have element, but here is empty. So since one is empty, one is including, then take as excluding. So this is going to be excluding. So for that case, we're going to say this is true. You see what I'm saying? It's a number line. Or if you want to write it as a one number line now, our new number line, let's say they might ask in terms of number line, then it could be like this. Look, I was going to say -3, right? But it's including, so I was going to do like this. And then +5, but it's excluding, I was going to do like this. And this is what we need. And then you highlight here, because remember it starts from -3 to +5, but this is excluding, so leave empty. See, so this is a number line, and this is the set builder notation, because they might ask you the set builder notation. So I could have said X are element of real number, and then I was gonna write my line and they say -3 to 5. So this is the set builder notation, and this is the number line, and this is -3 to 5 is in between here, because start from -3 to 5. So if you come here, this is true. A intersection B, -3 including, yes, it's including, all the way to 5 excluding, all the way to 5, yes, it's true. So this is true. Now we want to go for B and test. So for B, after the same strategy, right? Draw my number line and then allocate, and then show both. Because the thing is, you're not sure how they're going to ask in exam. Either it's a number line or interval notation. So when you work it out, practice both. Okay, for B, A intersection C. So that's my A intersection C. Well, I'll leave it. I don't know where you're at. It is A intersection C. So A is going to remind the same thing. A start from -3, but it's including. Okay. To infinity means this side. Oh, so this is our A. Now we want to intersect with C. What is the C? C start from -2 all the way to 7. Or -2 all the way to 7. So for A, this is -3, remember. -3 start from -3, it goes all the way that side. Now for, they say intersect with C. What is the C? Our C is -2 to 7. -2 to 7. Okay, let's draw a line here. If this -3, -2 is going to be somewhere here, let's say. Is including, excluding. A intersection C. C is excluding. Can you see? So -2 is excluding all the way to +7. Okay, 7, let's say, is here. But it's including. You see? This is including. So you put solid. So it's in between. So here. This is the area. So this is a number line. If they ask, represent B as a number, C as a number line, because A intersection C. So this would be C and this would be A. So C start from here, which is -2 all the way to 7 is a number line. So now, so this is separate. But now we want to see together is A intersection C. Intersection means where they have things in common. Now let's see what do they have in common. So the common is going to start from -2 all the way to 7, because after there's nothing here. So you say, okay, so it's going to start from -2 because here there's nothing, here there is something. So start from -2 all the way to 7. They're going to have common because it's going to have element from -2 all the way to 7. Can you see? Here from here. See? -2 to 7. See? But -2 is going to be excluding because this is excluding, here they have element. So it's going to be excluding all the way to 7, including because there's an element here. So this one here. Okay, here's another one. So -2 and this is 7. So this is a number line, and then this is going to be A intersection C. A intersection C. Okay, if you want to write as a set builder notation, you could say, okay, it must be -2, excluding X, including 7. And then here you can just say this is A intersection C. X are element of real number. You just say X are element of real number, and then you can write straight line stuff. So this is set builder notation. The set builder notation. See? And if you want to write as an interval, you're going to say excluding -2 means -2, excluding all the way to including 7. So including you write like this is a square bracket, and this is going to be like that bracket. Is an interval notation. And you can say X are element. But now let's go to the question. There's a question they want us to write as a set builder notation. So A intersection C, let's see. -2 excluding, -2 including. All the way to including 7? Yes, it's true. So this also is true. Now we want to go B union C. So I'm not going to erase this C, I'm only going to write B on top there. Because I don't want to do the same mistake I just did it before. Okay. Okay, so we want to do what now for the last one? B union C. C we have, so I just go to the B. B I can just rewrite it. Where is B? Our B is less than 5. So I can just say here, just do this. So if this is 7, so 5 is going to be somewhere here, let's say. But excluding, right? Okay, so we can just say like this. I hope it makes sense. This is B, because B, X less than 5 excluding. See, less than 5 excluding. So now what do we want? We want to get B union C. Oh, you see now? So now this one is not intersection, it's B union C. Union means put them together, join them together. Now let's go. So if I have to unite together, means this stuff is gonna start, look, it's gonna start from here everywhere, because even though here is including, excluding, even if there's nothing here, but it's gonna be something here because you unite them. So it's not gonna be, oh, there's something here, there's nothing here, so it's gonna be excluding. No, remember, you unite. So even if there's a gap here, this one is gonna come and fill it in here everywhere. So we're gonna say, oh, so our new number line is gonna be start from positive, because even there's nothing here, this is gonna be filling here because we unite. So it's gonna start from positive 7 all the way, because everywhere is going to be unite, but the biggest one is going to be positive 7. And then we can do like this. But here is our main thing. So this is B union C. Is a number line. But if you want to write a set builder notation like how they gave us here, I was going to say, oh, our x is going to be, remember here, so our x is less or equal to, this is 7, right? Because we unite. Is less equal to 7, and then don't forget to say x are element of real number, and then you close. This is set builder notation, number line, because like I say, not all the time they're going to give you representative. They can ask you either way. And as a set interval notation, I was going to say like this. You start from 7 on the right, and then on the left hand side, this side is negative infinity, because I don't know where it's going to start. So start from including 7 all the way to negative infinity. So, but for this case, they just give you a set builder notation. We can see this is a correct answer. So this is true. So A, B, C is true. All of them are true. A is true, B is true, C is true. Now let's go to question number 2. Number 7. Oh, let me just check if it does record, because yesterday I was recording sometime for almost 1 hour, and then I realized the camera was not recording. I was so mad. Okay, now let's go for this one. This is easy. So what I'm going to do, so I'll take left hand side, simplify, take right hand side, simplify. I'll rather take this simplify and take this simplify, whatever I can start with. Okay, let me start with this. 12 square root of 3. So mathematical, you rationalize the denominator and don't leave any root at the denominator is your final answer. So what I'm going to do, take this, multiply up and down, the same thing. Multiply by 3, multiply by 3. That's how we rationalize the denominator. We call it rationalize the denominator. Okay, so I'll take this, multiply up and down, and then when you multiply, this is going to give 12 square root of 3. But remember, if you multiply square root of x times square root of x is going to give you x. Why? Because this is going to be square root of x times x squared. You can put them together as 1 square root of x squared, and then look, what is this going to give you? This is x. So if you have a square root of same thing multiplied by the same thing, is going to give you 3. But 12 divided by 3 equal to 4, so this will be 4. So 4 square root of 3. Okay, so if we take left hand side, it's going to give us 4 square root of 3. Now let's take the right hand side and see what we're going to get. What is going to give to us? Okay, now so they give us 4, 3, 2, and then you got 3 here. So what we're going to do, I can simplify. This same is say 144 times 3. Why I do that? Because I know this is 3, so I'm going to introduce 3 here. Times which number? I know 3 times 144 equal to that number. And then divide by 3. So this is going to be, I can separate the root. It's going to be 144 square root times square root of 3. You can separate over 3. Okay. When you square root 144, you get 12. So then it's going to be 12 square root of 3 over 3. This is going to give us 4. 4, 3, 1. How many 3 in 12? 4. 4 is going to be 4 square root of 3, which is going to be equal to that. So left hand side equal to right hand side. This is true. Now we go for B. For B, interesting. Okay, for B, 18 and then 25. Square root, and here you got square root. So let me start to the left hand side. So what I'm going to do, I'm going to break this as a number which is going to give me square root. So I know I'll say 2 times 9 for a reason. And this is when you square root 25, you get 5. So now I can separate. So let me say square root of 2 and square root of 9. So square root of 2 and square root of 9 over 5. Okay, square root of 9 equal to 3. So it's going to be 3 square root of 2 over 5. And that's going to be my right hand, my left hand side. See? So now I'm going to take this right hand side and simplify, see what it's going to give to me. So this is 6, and then I got 5 square root of 2. Like we say, we don't need square root of the denominator for the most cases, so we have to rationalize the denominator. So multiply by square root of 2, multiply by square root of 2. So this is going to give us 6, and then square root of 2, and this is going to be 5 square root of 2 times square root of 2 equal to 2. Okay, now by 2, 1, how many 2 and 6? 3. So this is going to be 3 square root of 2 over 5. Yes, right hand side equal to the left hand side. So this is going to be true also. So true, true. Now let's go for the last one. So for the last one, 10 times 32. So let me start to the left hand side. 10 times 32. So what I'm going to do, this let me say, there's a lot of I can do this question. Okay, I can just say this is 16 times 2. So I can say this is like 5 times 2, and then I can separate. I can say square root of 5, square root of 2 for this one. Okay? And then we multiply. Same here, I'll say 16. This is going to be 16 times 2 for a reason, because I want to get number with a number which I don't like. I know this will give me 4. So I'm going to say 2 times 16. So it's like square root of 2 times square root of 16. I believe you understand. Okay? Because you can separate. This is 2 times 16. So square root of 2 times square root of 16. You can separate. Okay? So now I'm going to say square root of 2 times square root of 2 equal to 2. So this is going to give me 2. And then here I'm going to be left with what? Square root of 16 equal to 4. And this will be square root of 5. Okay? 2 times 4 equal to 8. 80 times square root of 5. So it's going to be left hand side. So you see, this gave us that, which is equal to this. So left hand side equal to right hand side. So all of them are true. So true, true, true. A, B, and C, all of them are true. Now let's go to question number 8. Let's see if it does record. Ah, yes, it does record. Okay. Now, let's go to question number 8. Okay, question number 80. So let's say if you consider only the value of x for which expression is defined, then like other one is like simplify this. See, simplify this is equal to what number? So let's simplify. This is easy, man. So first and foremost, okay, so I'm gonna say 1 over x, 1 over x plus 1, and then I'm gonna say minus 2 x plus 1 square plus 3 x squared minus 1. Okay, so what I'm going to do, we want to find the common denominator for all of them. Okay, so remember, first and foremost, let's split. This is a difference of 2 squared, because we know a squared minus b squared equal to a minus b, and then a plus b. So I can rewrite that as a difference 2 squared. So this, let me say, it's like 1 squared. So it's like x minus 1, x plus 1. So let me remove that and replace with x minus 1, x plus 1, or vice versa. So here we're going to have x plus 1 and then x minus 1, or vice versa, whatever. So now, which is going to be common denominator? I want to find the number which is going to be dividing for all of them. Okay? So, the common denominator here is going to be, I'm looking for the number that's going to enter for all of them. It's going to be this square. Look, if somebody give you, okay, let's say this is a, for example, it's going to be 1 over a. So x plus 1 equal to a. Minus what? This is going to be a square. And this is going to be what? 3 over a. So let's say x minus 1 equal to b. So what is the common denominator here? So this assume is a b, and this is a. X plus 1 is a, and x minus 1 is b. So this is going to be a squared, this is going to be a. What is the common denominator? So the common denominator, if you look careful, is going to be AB. for the number which, no. The number which is going to divide for all of them. The number which is going to divide for all of them. Excuse me, sorry. My phone is ringing. Let me just switch off this. Just a second, guys. The number we're going to divide for all of them. Not just A, B. It must be A square and B. A square and B is going to split. Is going to divide for all of them. Because look, if you take A square B divided by A, yes, I'm going to get something. This divided by this, yes, I'll be left with B. There, AB. You can extract AB from here. You can extract A square. You can extract that one. Do you understand what I'm saying? So, what about AB? You cannot, because AB, this A square cannot go in AB. So in other words, whatever, all this stuff must be gotten into here. Here you can get A, here you can get A square, and here you can get AB. Can't you see? But if I say, okay, the common denominator is AB, it's not going to be possible, because you know what? A square cannot be obtained here. That's a problem. So now, for that case, so I'm going to say my common denominator for all of this is going to be what? It's going to be x plus 1 square and x minus 1. This is like A square B. I hope it makes sense. Okay? So if I know that's my common denominator, then I can say multiply each of these by this. For each of this group by this. See what I'm saying? So multiply each of these groups. So I'm going to say, okay, let me start here. So I'm going to multiply by x plus 1 square times x minus 1. Okay, same here. X plus 1. So you multiply by the common denominator and then x minus 1. Same here. It's going to be x plus 1 square, x minus 1. So for that case, we can simplify some of them. X plus 1 and 1x plus 1, they go. X plus 1 square and x plus 1 square go. Now, let's come there for the last one. Let's go. This is like multiplication, right? Okay, now we go here. So we say x minus 1, x minus 1. 1x plus 1, 1x plus 1. So for that case, we write what we left with. So here, on the first group, I'm going to be left with what? With x plus 1, x minus 1 on top, and the denominator, nothing. You see? So the denominator, write our common denominator. The one that we say is common for all of them. What is that common? This stuff, which is x plus 1 square, x minus 1. Write the denominator. Now, let's come here. This going to be minus just this one thing. Okay, I should have said this. Let me say this, excuse me. When you multiply, not all on top, you must multiply top and bottom, top and bottom. So when you multiply on top, also put at the bottom. Same thing, top and bottom. So top and bottom. Same for that one. Okay, so at the bottom, can't you see it's going to be common. So here on top, since we cancel this, we're going to be left with what? With x plus 1 and x minus 1, but at the denominator, we're left with this, which is x plus 1 square, x minus 1, and then minus, so we're left with 2 and x minus 1 here, and then we're left with x plus 1, x minus 1, because we multiply top and bottom, so this in the cancel, so we say, okay, plus 3 multiplied by the x plus 1 at the denominator, we say what? X plus 1 and then x minus 1, which is this. See? So what we can do, we can just put them together. Or, before I put together, another way you can do, before I put together, let me show you something. I'll come and put together now. Okay. Or another way you could have done, it was what? 1 and then x minus 1 and then minus 2. So then you can choose to see which is going to be easy for you. Plus 3, because I don't want you to get, I'm used to the other method now. What are you doing there? What are you writing? You see? And then we say, okay, let me write the last one. Okay, just a second, because I kind of erased there, so I want to get a question, okay? Okay, I see. X square minus 1, okay. X square minus 1. X square minus 1. But what is x square minus 1? Oh, it's just this one, sorry. X minus 1 and then x plus 1. So what you do, find the common denominator. So the common denominator, it's just going to be what we say is x plus 1 square, x minus 1. You don't want to say common denominator, the number which is going to go for all of them, just like I'll show you. So now take this number, divide by this. If you take this, remove this from this group means 1 is going to go. Take this, divide by this, like saying x plus 1 square, x minus 1, and then divide by x plus 1. So this and this is going to go. So we left with x plus 1, x minus 1. So say x plus 1 and then x minus 1. So we're done with this. Now we come for the second one. So see which is going to be easier for you. So now we say, so you see you wrote the common denominator, the denominator here and in our line. Take this, divide by that. So can't you see? This and this is going to cancel. So we left with x minus 1 times this 2. So we say 2 x minus 1. You understand that? Because this and this cancel. So we left with x minus 1 and then multiply by this 2. Now we go for the last one. Plus 3. Take this, divide by that. So look, x plus 1, 1x plus 1 is going to go. And x minus 1, x minus 1. So you left with x plus 1. So you multiply by 3. X plus 1. I think that could be more easy. So see which is going to be more convenient. Can't you see? Give it the same answer. So see which is going to be more convenient for you. Go for that. So what we do now, we can put this together. So if you put the two, because this is the same thing. Now let's go. So now I'm going to say, I can put this stuff together. This is the difference of 2 square. X plus 1, x minus 1. So it's going to give us x squared minus 1. Because if you have a squared minus b squared, this same as say a minus b, or you can say a plus b. So if I have a that, means it's a squared minus b squared. That's to say this equal to that. Okay? Now we come here, we say minus bracket, and this conversion is going to be 2x, or you can just multiply straight. So what is our common denominator here? Let me do this. Let's use this. X plus 1, and then square x minus 1. Oh, multiply x minus 1. So now let's come here. This is going to be x squared minus 1, and then minus 2x plus 1 plus 3x plus 3. Okay, so let's put them together. So when you put them together, this is going to be x squared. Now let's go. This and this cancel because it's going to be the same thing. Now we go 2x plus 3x equal to 1x. So plus x 1 plus 3 equal to 4. Now you come at the denominator. You write x plus 1 square and then x minus 1. And this is going to be our final answer. Okay, for this question. So this one right here is going to be our final answer, and it's easy like that. So as far as here, see which is going to be more convenient for you, because some students sometimes have a different way of doing. See which is going to be more convenient for you. Look, if you first time here, make sure you subscribe. If you the first time, if you haven't, make sure you click the like button, because means if you do that, means it's going to reach to more people. Like the button, leave the comments. I'm going to respond to your comments, and thanks a lot for your time. Peace. Peace. I'm out.